On my right, we have Oleg Drokin, HPDD Intel. On my left, Sumimoto-san from Fujitsu. They're going to talk with us about Fujitsu's contributions to the Lustre code base. And with any luck, this will look swell. We're not cutting the top off much? No? Okay. Thank you. Thank you.
Hello, my name is Shinji Sumimoto from Fujitsu. Today I'm going to talk about Fujitsu's contribution to Lustre 2.x roadmap with Intel or Oleg. So at the beginning of this talk, we are now trying to our Fujitsu the extension to the Lustre to the Lustre 2.x. So the purpose of this talk is we are describing such kind of our schedule and what kind of modification to the future Lustre, and give the audience the feedback to our future activity. So I'll talk about the next. So here's the outline of this talk. First, I talk about FFS and FFS extension overview. So then I talk about the contribution of FX extension to Lustre 2.x and current status and schedule. So I talk about it. So here is I talk about the overview of FFS. This is President Sergio is president at the LUG 2011. So our goal of to develop the FFS is to realize world top class capacity and performance file system. Our goal was 100 petabyte and 1 terabyte per second. And the file system FFS is based on Lustre file system with several extensions. And our goal is two. One is fast file system, and the other one is capacity and reliability. So we introduced the layered file system on each file layer characteristics. And for example, maybe here's a Lustre and FFS based on the rest. However, maybe there are two file systems in FFS. The lower level is for a global file system for with the capacity and reliability, and the top of the file system is work temporary for performance. So we come to make together for easy to use using staging. Here's an overview of FFS. And here, this specification was also presented at LUG 2011. And we extended, current Lustre is here, extended file size system. It currently is 64 petabyte. However, our goal is logically 8 exabyte, and we tested in 100 petabyte. And also, we extend the file system size, number of files, and also max OST size, and max stripe count, and max await entry to improve some performance. Also, from the development of the K computer, there are many of OSSs. Current Lustre is limited to 1,000. However, we extended to the 20 kilo number of the OSS also. So we extend also the number of OSTs, and the markups number is also extended to 1 million. And to make a large performance, we extend the block size of LDXS up to 512 kilobytes. So this target is, was contributed to the OpenSFS at 2011. So here's a Lustre extension to FFS. So we have extended several Lustre in compatible with the high performance, and it's ParaIO and MBS response and IO zoning. And it's also bring the scalability. This is provided by the backend file system and the max file system, something like that. The other four parts of the communication and for operation and interoperability and reliability. So, SC11, we we are in one cloud now in the Intel have a press release. However, we are talking. We have been with Fujitsu have been talking about Lustre community since 2008. Since 2008, we are discussing the sun, and after that, we are the Oracle. But it is not working well because they are going to business for other Lustre. However, the one cloud developed in 2011, so our collaboration is accelerated faster. So we are making press releases on IC11. So we one cloud and Fujitsu collaborate on the Lustre development. So that is the beginning of our step. So I talk about some our progress since in 2011. And there is a 5 periods. So the period 1 is December 2011 to March in 2012. So the phase we invited Oleg to the Fujitsu and reviewing what the difference of the Lustre code and FPS. And the phase is a selection of Fujitsu extension to the Lustre 2.0 by Intel. So we are discussing there are extensions 60s. However, for making a policy, it is important to modification. The basic Lustre is very important to adapt to earlier phase. So and the second step is from the April 2012 and making proposal by Intel. So we scheduled a 3-phase proposal. The first phase is also finished. However, the topics are architecture interoperability and LNet and OSS Zeta update. And second phase now goes on and with the memory management modification to Lustre. And third phase is for a large-scale performance and OS management. And here is 20 selections selected Fujitsu extension to Lustre 2.x. And here's the number of red one is the first phase. Here's number 1 to 3 shows such as network hashing and root properties and read performance root file. So 4 is maybe a memory reduction. And blue lines are stage 3, sparse OST and OS selection, and maybe a resource unnecessary data transfer. And for the 20 of selected, is now to the modifications. So current schedule is already studied with Intel applying the FFS extension to Lustre 2.x, and we plan to finish by middle of 2015. A major big step is finish step 1, not step 2. So maybe step 1's modification to will be 2.5 or something like that. So my presentation finished, and I changed to Oleg.
Hello. So I will dive into a little bit of more details of works that we are doing together with Fujitsu, and like Sumimoto-san mentioned, they shared their code with us that is based on Lustre 185, and we inspected it carefully, and we split it on a per feature basis. We then further categorized the features in a way that certain things that were very important, certain things that actually were already done in 2X releases differently, or just done in a similar manner but no longer needed to be ported, and then certain things that we didn't really agree with or otherwise didn't want to really deal with in a short or like medium-term basis for various reasons. And so we split everything into 3 phases, and I'm going to explain a little bit about things that are close to being landed or that have landed from the phase 1 and partially from phase 2 of those actions. So one of the things is the network jitter. Like probably those of you who run large systems know, the pings on large systems are kind of expensive. A couple of years ago, Eric had this great slide with running pings during his health network presentation that kind of really shows you the impact. I wasn't able to incorporate it here, but the impact is really large, and health network seems to be still quite a bit off, and people are seeing these problems right now. So we kind of looked at this problem again, and so what were the two main purposes of pinging? First, it lets clients to detect servers that have restarted in a timely manner, and then it also proactively weeds out unreachable or dead clients. So kind of a needed thing. With recently implemented imperative recovery, we've really got the restart detection covered. But that doesn't mean it would allow us to drop pinging completely yet, because the dead clients we still need to detect. Otherwise, when you are trying to work on a resource that the other client has a lock for, well, you need to wait for a timeout before you can kick out that client, which is slow, and nobody wants to do that. But on the other hand, lots of vendors already are including a solution in their system to detect those dead clients, because they need to know not to schedule jobs on them and stuff like this. And in Lustre, we actually have an API where those systems can actually inform Lustre that, hey, look, this client is dead, so just kick it off. Combining those two together, it actually really does allow us to do away with pings. And so basically right now, and this code is already landed, you will be able to tell the servers where this is supported that, hey, you can let clients know they may no longer ping you, and this problem is solved. Of course, there is a third reason why we need pings, which is to actually query servers when there's uncommitted data so that the clients can release their state associated with that when the commit happens. And this particular kind of pinging is still there, but it only happens when there is actual activity, so it's not an idle pinging. The other thing that Fujitsu has noticed that nobody have noticed before, I guess because they have the largest routing deployment, is the routing table in LNet is kind of strangely done. It's just a linked list, so when you have 1,000 of routes, you really need to iterate 1,000 of entries in the unluckiest case. So right now, we took their code, we improved it a little bit, and the routing table is now a hash table with a varying number of entries. You can control that manually, or if you don't, the system will try to second guess the amount of table based on how many entries you actually have. So this is actually a pretty simple feature, but it's going to be useful for those of you who do run lots of routed networks, so the fine-grained routing at like Oak Ridge, I guess. The other kind of surprising message we've got from Fujitsu is the LDLM pool D actually takes lots of time. And when I first heard about it, it was kind of surprising. So like 2 milliseconds on a 2000 OST system on every client is kind of a lot. So I dive into that, and I found that there's really no good reason to do that. The previous implementation, basically, regardless of whenever it was running on a server or on a client, was walking through all namespaces and checking all of them whenever it's time to actually update certain statistics. And it was doing it for both the namespaces that were empty and not empty, client and non-client. And the number of namespaces on clients really does add up. So I have patches ready, but kind of too late for 2.4, going to be in 2.5, I guess, where the namespaces are now split into two kinds of namespaces. The one is the namespaces that do have locks, and the other kind of namespaces where there are no locks. When there are no locks, there's nothing to update, so those we will just skip. And when there are locks, the client namespaces actually are different from the server ones in a way that they only update the statistics every 10 seconds. So the thread is woken up 10 times in the course of 10 seconds right now, but it kind of walks all the namespaces and goes to sleep 9 times out of 10, which is a great waste. So now we are actually able to determine when is the next time the thread should wake up, and on clients the load is reduced dramatically. We have some testing from Oak Ridge that shows that CPU utilization basically is no longer noticeable at all after running for several hours. But that's kind of the easy fixes. What I have also determined during my analysis is lots of those client-side calculations, they are pretty linear, and so there is no need to wake anything up until the server tells us, like, hey, look, the log volume that you are kind of operating on have changed and you need to do something. So there's a great potential for client-side LDLM pool D to go away completely, but it's kind of more of a later task right now. The other thing that I guess is mostly important for Fujitsu, but it's still a good exercise for everybody else because of different architectures bringing other benefits like cleaner code and such, is the Spark architecture support. Spark is a big endian architecture, and typically people do run on little endian x86. But there are other guys like Lawrence Livermore runs on PowerPC. So Fujitsu actually performed a full Lustre source code audit for endianness issues, and they have this gigantic patch including all LNDs, even those they don't use, and stuff like that. Unfortunately, it's totally 185 based, so it overlaps with the current code only at about like 50% level. We are taking that, we are using the parts that we can use, and we are now auditing the other 50% and trying to correlate the changes that were before in like areas of code that were rewritten to make sure that we are not repeating the past mistakes and stuff like that. And additionally, a unique Spark architecture problem is the Linux on Spark uses a different error numbers from other Linux architectures because they wanted to be compatible with Spark Solaris. So when something sends a ESTAIL from a Solaris server to x86 server, the x86 client actually sees a totally different value. The Fujitsu developed a translation table for just on the network error communication, somewhat similar to what NFS does. And so this is what we are taking and we are incorporating into 2.5 release, I guess. At least the code is pretty clean and almost ready to go, and it's just, we are not really taking any more things into 2.4. Additionally, Fujitsu contributed access to a Spark system test cluster so that we can actually make sure all of this works. Yet another thing that Fujitsu noticed is when you have lots of servers, the clients tend to allocate lots of data for statistics information on those servers, and not everybody cares, especially now that we have server-side statistics on need-based statistics. It doesn't make sense to a lot of people to do this. So they implemented a neat solution where you can just specify a mask of, like, I want statistics from those layers and the rest shouldn't be allocated. So we are actually taking this solution and incorporating it in one of the next last releases. And finally, the one of the more ready features is the fine-grained control of striping. So the way we do striping right now is kind of coarse. You can specify the starting stripe and how wide the striping you would like, and that's it. This doesn't cut it for lots of people, like especially Fujitsu, because they also have the other feature where their OST numbering is not sequential, but it's kind of split into bits, and each bit shows like this is shows location information basically. So their OST striping is not contiguous, and they really want to allocate certain objects on certain physical locations. So basically what this does is it takes the current striping and allows you to specify allocation server by server. You can say that this particular file I want objects on OSTs 1, 7, and 15, and that will work. So again, this is something we've taken from them and that requires very little changes on our end. And that's it.
Questions for Oleg or Sumimoto-san? No? I'd like to thank you both. Thank you.